on getting our builds converted over to JIP along with Brad Nelson. And so this is to kind of try to give everybody a little bit of background, actually just an overview of what we're doing and give you some patterns for things that you'll probably hit in starting to learn how to deal with a JIP generated build. One reminder, because we are recording this and the intent is to actually make this available publicly, keep that in mind in questions, no proprietary information. And there we go. Okay, so just to make sure we're all on the same page here, what is JIP? It stands for Generate Your Projects, and it's the brainchild of Mark Mentavai out of the New York office and the Mac team. So all of the good stuff you can attribute to him. The struggles are all coming from the local folks. What we're doing with this is it's a build tool for generating configurations in multiple other build tools. It particularly can generate build configurations in the list you see there. Xcode, it started with Xcode, which has actually probably the most, I think, sophisticated model of the tools that we use for building Chrome. Also does Visual Studio, Scans, and then there are two in-progress prototype versions of backend generators for Makefiles that Evan's been doing and Forge that AGL's been doing. And part of why we've been going down this path is that JIP is really specifically designed for our needs. That having been said, it's really kind of evolved into something that could be applied to a variety of projects, but the thing that really makes it successful is we get to tailor it to what we want to do. All right, the key characteristics here are that the generated configuration files actually drive the build. So we get native build out of Visual Studio, we get the native Mac build. The IDE stays the center of the workflow because that's a really important part of everybody here being productive. Second thing to be aware of is that JIP is a static data representation of the build, essentially. There's no scripting inside the JIP configuration files. What you have is the build configuration, i.e. the settings and the flags that are going to get applied to building the different targets, and then dependencies, being able to say that Chrome.exe needs these particular libraries to link. Now, that having been said, even though it's in a static data representation, there are variables that can get interpolated. It does have conditions that get evaluated to create different flavors of builds, and there is even talk about putting loops in there in the near future, so we're getting close to Turing completeness. The input format in a JIP file itself is actually JSON. Although we have two syntactic wrinkles on it, it's really more of a Python dictionary. The two things where we deviate from strict JSON compliance are that the comment character is a hash, and that a comma can actually appear at the end of a list of elements, which JSON forbids. This way we actually just suck it in as a Python dictionary and evaluate it and go from there. Part of the goal here is to keep the workflow really simple so everyone can be productive. So the basic idea here is that when you're making a change to the build configuration, you edit .jip files, one or more. That might be adding your source files, modifying settings, adding a new target. The key thing to actually get JIP to do its magic right now is to run gclient runhooks -- force. Now, you may have seen already, in fact, you undoubtedly have seen at the end of doing a gclient sync, gclient is doing runhooks. When it's doing gclient update or gclient sync, what it's actually doing is running the hooks, but without the -- force, it's only going to generate new files if it thinks that there's a reason to do that. It's basically doing a small dependency analysis. Better when you're doing your own stuff, just be sure to run it with -- force. That makes sure that all of the generated VCproj files or Xcode files are all up to date with your .jip files. Then at that point, either reload changes in your IDE, or if you're superstitious, go ahead and restart your IDE. I tend to restart everything just to be completely sure. At that point, you should be able to build like you normally do in the IDE or from the command line. And then after that, it's the normal workflow of GCL upload, let the try servers do their stuff, and commit when you're ready. Okay, the overall target model that JIP's got here is that each .gyp file that you'll find in the tree contains one or more targets that are kind of related to whatever component that gyp file is defining. Every target within there is just some chunk of software that we're building to, to end up building Chrome. Typically libraries, those are the most common targets that we've got. Executable programs are a close second, but there can also be targets to create resource files or specific shared libraries or static libraries. When we get into the examples, you'll see the list. And what these target definitions inside a .gyp file express is not only how the target should be built, but the dependencies between the targets. The dependency information in gyp really accomplishes two things that are really useful to us. One is the actual ordering of targets, making sure that the library is built before you actually need it on the link, and then being able to share and export build settings in between targets. So for example, anything that's using gtest, we want to make sure is built with -d unit test, and gyp makes that pretty easy to do. And you'll see that when we get into the examples. Organization. In general, what we've arrived at so far is one .gyp file per major directory component in our tree. So we've got base.gyp, net.gyp, the ICU38.gyp, and so on. The key exceptions here are that Chrome and WebKit are big enough that they've got some subsidiary .gyp files in there. What we're going to be doing after the conversion is completed is kind of trying to take a pass to make this a little, more regular and make sure we're, that things are relatively comprehensible so people can understand where to find the files they're looking for. There are a couple other minor outliers beyond Chrome and WebKit, but in general, we're trying right now to get to one gyp file per component. And that .gyp file for that component contains all of the relevant targets for that component. So in the case of base, it's building base and base unit tests. In the case of Chrome, it's building not only Chrome.exe and Chrome DLL, at least soon, but also the unit tests that go into testing Chrome itself. Now, the one directory that's not just like the other components is build, and this has got the kind of system central, or at least the configuration files that are central to our configuration. And in particular, these 5 files it's worth knowing about. First one is build all.gyp, and what this has become is this is going to be the master file that pulls in all the .gyp files for the entire configuration. Be aware that this is the file that runhooks actually looks at when it's generating all the files. The reason why that's important is if you go off and add a new target to some other component like Chrome, or you add a new gyp file, it's actually a completely new target, and you don't list it in here, the trybots and the buildbots are not going to know anything at all about it. So this is where you add that stuff. Second important one is build common.gypi. Gypi is for gyp include. There is an include mechanism in the gyp files. And build common.gypi contains all of the common build settings that we've got. Inside it, it's got conditions for the different platforms. So that's where we've got all of the Windows settings, all of the Mac settings, all of the Linux settings, as well as the compiler settings for things like code coverage and purify and valgrind and the like. So if you end up needing to make changes to global settings, that's where you go. Related to common.gypi, there is a build external code.gypi. That ends up getting included by any .gyp file for a component that originates outside the Chrome project. The stuff in third party, for example. The real key effect here is that for those components, we end up removing the WError and WAll because since we don't control those source bases, we can't enforce that they're going to build completely error-free. Common.gypi for our stuff actually turns on WError and WAll because we're trying to actually encourage all of our components to be completely warning and error-free. The other two ones that probably won't affect too many people but are still good to know about are the system.gyp files for Linux and Windows. This is where we end up doing some system-specific initialization to set up things. In the case of Linux, what we're doing is going out and running package config to find the system libraries that are needed for our build. And on the Windows case of Windows, we're actually doing Cygwin initialization, setting up the mount points so that you don't have to do that by hand, or we don't have to run around and do it by hand on the build bots. All right, now, what actually gets generated when you run gclient run hooks -- force. This is useful not only because you might want to know where to look for these files, but it also kind of helps map the mental model that you probably already have from working in Visual Studio or Xcode to what JIP's doing. In the case of Windows, each .jip file maps to a generated .sln. And each target within the JIP file maps to a .vcproj file. So keep that in mind if you're trying to think of, oh, I would do this with a, by going into this project file in the old way of doing things. Where is that? It's going to be a target in an appropriate .jip file. If it's something at the level of the solution, you're going to be dealing with the .jip file that corresponds to that SLN. In the case of Mac, each .jip file generates an Xcode proj file, partially again because the Mac was kind of first out of the chute, and so got to set a lot of the ways in which we define projects so it would work well with that relatively sophisticated Xcode model. And on Linux, each .jip file corresponds to two generated files, a sconstruct and a target underbar main.scons file. The separation is there for some future flexibility that may come into play. And then each target within a .jip generates one .scons file with the base of the file name being the name of the target. So it's going to be chrome.scons, base.scons, base underbar unit tests.scons. Okay, and then before we start diving into looking at actual code, so here's where we currently are with things so that everybody's on the same page and we're all clear. Right now in our tree, everything is converted to work with JIP except basically chrome.sln and all of the stuff that's in chrome.sln. Right now, I'm in the process of trying to finish off that conversion. Secondly, the JIP-generated WebKit build is there on Windows, like all of the other components, but we do know that it is, in fact, slower than the vcproj files that we had before that were just directly built and checked in. Brad Nelson is working on tracking down some of that. He's already found part of the issue, and we're going to continue looking at what it is that's introducing the slowdown. The scons build on Linux is slower than we'd all like, and has definitely got different issues. So one of the things that we want to do is we want to take some of the prototype work that Evan's been doing on a makefile generator and look at it and see how close it is to being productized. If it looks like we can actually pretty easily productize that and have it handle all the dependencies correctly, then we'll probably just go ahead and have make be the official build on Linux. Another issue that's out there is that the .jip files right now, because it's basically one .jip per component, they are pretty big. And it's pretty easy, particularly in the long lists of source files, to get lost and not be able to keep track of which source list you're in, particularly in chrome.jip. I mean, browser's got like literally about 1,000 files in it, and you're scrolling up and down trying to find exactly where, which list to add your file to. Once the conversion is finished, what we want to do is split these files up in some logical way. We still have to work out exactly what's going to make the most sense, but split them up in some way so that at least you can know, oh, I'm in, the browser.jipi file maybe, so therefore I know I'm working on the browser, list of files. Another nit that probably isn't going to affect most of you day to day, but if you build release builds on Windows, right now the release build is using checked-in VS props files. The debug build is not, so there's a slight difference there that has to be part of the follow-on work to finish this off. And then the last one is, if you've looked in a JIP file, there are these MSVS GUID entries. You'll see them in some of the examples that I'll show. And those are going to end up going away. They're basically a transitional element. So take that current state of things, summarize it. What do you do now? What do you have to be aware of? First off, if it's outside Chrome, just deal with it in JIP. Everything outside of Chrome is or should be JIP generated right now. So just go ahead and modify the appropriate .jip file and do your normal check-in. If it's inside Chrome and it's a Mac or Linux only module or file, then you're still just within the JIP world. So you're in chrome.jip, build, check-in as normal. However, until the conversion finishes, hopefully next week, if you're in Windows and if you're on Windows adding a Windows file, probably the best bet is add it to Visual Studio as normal. But then please, 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 if you can remember, add it to the chrome.jip file too. Now, that sounds obvious, but the thing is the trybot's not going to tell you that there's a failure if you forget to list the .c file in the chrome.jip file, because the trybots aren't using chrome.jip yet. So you can go ahead and leave the files out there. Trybot says everything's good. You check it in, and you're not breaking anything. The reason I'm kind of pleading with everyone to try to keep that in mind is I end up, kind of losing time in finishing the conversion to having to kind of constantly play catch up. So as much as possible, if you can do that, it's a huge, huge help. Another thing, when that conversion actually happens from chrome.jip to chrome.sln, there's going to be a change in what chrome.sln builds. JIP's model is that when you're in a component, the only things that are built out of the solution files generated for that component are the things that that component cares about. So when you're in base, you go ahead and build from the generated base.sln file, it's only building base and base unit tests. We've gotten very used to chrome.sln being the main entry point for building the entire world. The build bots all use chrome.sln as the main entry point for building the entire world. When we first cut over to the JIP generated chrome.sln, we're still going to do that so we don't break the build bots, but shortly after that, we're going to get rid of the inclusion of the entire world into chrome.sln. And at that point, chrome.sln is only going to build basically, the chrome.exe, chrome.dll, the Chrome executable, and the specific unit tests for Chrome, unit underbar tests, and a couple of the others. The thing for building the entire world is going to be over in the build subdirectory, build all.sln. We'll obviously send out big, announcements when this actually happens. On balance, I think this is actually probably going to be, an okay thing, because if you are only working in browser, for example, you don't necessarily need to be building the entire world. So it will hopefully restrict the, scope of what's being built for people in a useful way. Okay, now that as background, let's start taking a look at what the .jip files look like. This is the skeleton of a .jip file. These are basically the 5 main sections that show up in our .jip files. We're going to go through them one by one. Okay, first the variables section. This has got JIP definitions of JIP variables that can be used in the build. The most prominent way that these are used is in the condition blocks that you see down at the bottom of the file. But they can also be used to define things that, like file names that get interpolated in particular lists of source files, and can be used in other contexts. But the most prominent way you're going to see it is in conditions. The most prominent variable that you are actually going to see defined is the one here, chromium underbar code. What this does is basically turns on the -w all and -w error. It identifies to our particular way of using JIP, this is something that we control the source code on, so we're going to enforce that this code is warning free, so go ahead and do all that magic. You're going to not see that variable in any of the third-party components. The gray area, of course, is components where it originates outside Chrome, but it's maybe originates from Google, and we kind of know that this code is warning free. The recommendation is still leave this variable out for those components, because the fact that that upstream project is enforcing warning-free code is not necessarily something that we should be relying on. We shouldn't be doing their enforcement for them. For example, maybe we end up, porting this to, some tool chain that ends up generating warnings, and there's a gap of time before we can actually get a fix upstream, to suppress the warnings. We may need to have that flexibility. So leave it out. Only use it for stuff that really originates with the Chromium project. There are a bunch of different variables that can be used, that are used by different JIP files to affect their build. Most of those are actually defined at the top of build-common.gypi. Build-common.gypi has its own variable section. It's growing fairly extensive. There are about 8 variables right now that we have defined on the wiki to affect how the build does things. And the one thing I'll point out here is that there is an OS variable. That's the thing that actually defined by the JIP tool itself. OS equals Linux in this case that we have here. There's OS equals Win, POSIX, and Mac as well. Next section, includes. This is a JIP include, not a C or C++ pound include. This is how all of the JIP files get the common settings from common.gypi in there. Right now, when you look at the JIP files, you'll generally only see this include. My guess is that as we figure out how to subdivide the JIP files in ways that we're going to end up having more of these as we find sections of the JIP configuration that do need to be in common across multiple .gyp files. Path names here are relative to the .gyp file that you're in. That's consistent in all cases in JIP. One simple rule relative to the .gyp file. And in general, every JIP file in our tree should include build-common.gypi, so you should be able to rely on the settings there. Okay, next section that you'll see is target defaults, or maybe not. This doesn't show up in every .gyp file. And what this is a dictionary containing the settings that are going to just apply to all of the target definitions in that file. The most common things that you find in there are the defines, your C preprocessor defines that end up on the command line, and the includers that show up in your -i or /i option on the command line. This is also used to define for most of our common components exclude patterns that automatically throw things like an underbar win.cc file out of the sources list on any non-Windows platform. Same thing with underbar Linux, underbar platform, those things I mentioned. Okay, the targets section. This is really the meat of most of the .gyp files. What you've got is a list of dictionaries. Each dictionary is a definition of a target, and we'll get through this file, and then we'll dive into what the skeleton of a target definition looks like. And the last is conditions. This is worth spending a little time on because this particular idiom can really show up in just about any dictionary that you care about in one of the .gyp files. It is how we actually do platform conditionals, things like conditionally turning on the options for code coverage, Valgrind, Purify. Each element in the list is itself a list that's got a condition string that's going to be evaluated against the defined JIP variables, and then one or two dictionaries of settings. The first one, it gets applied and merged into the containing dictionary if the expression evaluates true. The second one, if it exists, gets merged in if the expression evaluates false. Most typical uses for platform-specific platform-specific targets in this context, being able to define that setup.exe is something we only care about building on Windows, and some of the other utilities are only things we care about building on Linux. Less frequently, you'll see this used to set different values for variables or to put different defaults in the target defaults. That takes us out of that. I should actually remember to pause occasionally. Are there any questions on any of the stuff that I've covered so far? So that we don't lose too much context. Say again?
I have a question from New York here about the variable section. Is there any sanity checking going on? Like, for example, if I don't specify the Chromium code variable, will there be an error? Another question, if I accidentally override the OS variable, is that also an error, or is that okay?
Okay, the first part of the question, if you don't define a variable, is there an error? If you try to use it and it's not defined, yes, there's an error. So in general, what we do is put default values in build common.gypi for anything that we really want to make sure exists. And then you have the target specific or GYP specific definitions in the other .gyp files. And then the second question about OS was?
Can I override OS in the variable
Can you
section?
override it? No, actually that's defined by the GYP code itself.
Okay.
You can, however, when you invoke GYP, give it an option to build with a different flavor of generator. By default, if you're on Windows, it'll build, on Windows, but there's a -F option that'll let you, build the Windows VC proj files even on Linux.
But the general model is just environments or dictionaries are overlaid with the variable section. Is that sort of correct?
I'm sorry, you got a little faint there.
The model of how variable sections are handled is that you just overlay the dictionaries over some default. Okay.
Exactly. For example, the settings in a condition when it evaluates true end up, merging in and overwriting those values. Yes. The question is there a way to append or unset variables? Yes, there are ways to do that. We'll cover those in a nutshell. If the default behavior in a dictionary like the conditions dictionary where you've got a variable set, if it's a variable, the default behavior is to overwrite. If it's a list that you're dealing with, the default behavior is to append. But if you tack an equal sign on the end, that says, no, I really mean to overwrite this variable. And if on the end of the name of the variable, like LD flags, and if you tack an exclamation point on the end, that indicates please remove this this value from the list I'm affecting. So we'll see some examples of those in some of the use cases. Another question in Mountain. What's the priority between the includes, the local definitions, and then the conditions? Mark Metava, are you there? Because I'm not going to get this right. Nope. Okay. What ends up, if I remember correctly, and I'll double check, and if I'm wrong on this, I'll send out some follow-up mail. But you have the basic target definition that's in the .gyp file. For instance, what we're looking at here, we've got the open and closed braces. That's the basic dictionary you're dealing with. At the point that it hits the includes, it's going to merge in. Oh no, it's not at the point it hits, because this is static definition. It goes through and applies the includes. And because the includes may affect the conditions that you want, you've got to have those variables set. Then it goes through and does the conditions. Things can get hairy when you can have really complicated, arbitrarily deep nested conditions. There's nothing preventing you from putting a condition, for example, within those dictionaries that are in the conditions. For instance, you might have, on Linux, you've got your conditions section, and then within that, you might, you're going to have maybe different conditions for code coverage versus, non-code coverage. And it can definitely get complicated. When in doubt, get help, because it still buffaloes us as we're trying to make sure we get all of the things that we used to do with the old build to work in equivalent ways in this new stuff. The question is, it sounds like that the include overrides what's in the JIP file. Is there a way to? That's got to be you're right. Yeah, Brad's weighing in here. It's the includes and then the specific into the .jip file. Okay. More questions? Another in Mountain View. Yeah, the question is just to verify that the curly brackets are dictionaries and the square brackets are lists. Yeah, this is basically a Python dictionary. Think of it that way, and you can't go wrong. I'm sorry, say again. Are the the apostrophe. The apostrophes are just quoting strings. Nothing more magic than that. Okay, any others? All right, let's dive into the targets then. Okay, now just to make sure we all have the right context, what we're going to be looking at now is that section, the dictionary that's within that section labeled targets that says target name, my target, target settings. We're going to look at what one of those looks like, because this is where you're actually going to be spending most of your time trying to deal with configuring the build here. Same way we'll go through one by one these different components. This is not by any means all of the things that can show up in a target. When we get past this to additional use cases, we'll show you more fun things you can do with these. But this is a pretty good skeleton. First one, the target name. Right now, this is what's used as the name of the Visual Studio project that's generated. It's the name of the target in the Xcode config. And it's also the name in the scans build that's used as an alias that you can say from the command line, build base underbar unit test. Because of that last one, currently at least, this name needs to be globally unique in our configuration. We're looking at potentially relaxing that restriction as part of the follow-on work to evaluate what we want to do on Linux. Second, the type of the target. On the left hand, you've got one there that's an executable, which of course is just building an executable program. We want to highlight that actually the most common target type that you're going to see there is this funky string here with the less than and the parentheses. What that is a JIP it's the interpolation of a JIP variable. By default, the JIP variable library is defined as static library. But when we use this, it gives the user, particularly on Linux, the ability to redefine the library variable as shared library and do a shared library build. Particularly for the Linux folks, this ends up being a really huge win. The link times are significantly shorter for shared library builds. Different types that are known are static library, shared library. We've got loadable module for things that are shared library-like but don't have all the same stuff. Settings, and then there's a catch-all none. You can literally say none, and we end up using that in a couple places for targets where there's really nothing but a custom build rule. There's nothing else we can identify it as. Yeah, question in Mountain View.
Yeah, so one of the problems with sconce is it doesn't know about, because I did the related on the Mac version of OPD, it doesn't know about bundles. The bundle isn't really, it's a special kind of static library. You can pass that bundle.
Okay. The question is about scans at least not recognizing bundles, and that's true. That the backend, the scans backend, isn't going to fix that. Oh, you do? Okay. You're not using Xcode for it? No. No. Okay. Right. Okay, so the question is requested if JIP actually had some specific recognition of bundles as a distinct type. Okay. Okay, then the other thing to be aware of is that actually unknown type values will not generate an error. It's up to the individual JIP backend generator to interpret these things. The good side of that is we can go ahead and add new types and not have to make the entire world aware of them. You know, the downside is it doesn't catch things like, you know, misspelled type strings and the like. All right, this was the MSVS GUID setting that I mentioned previously. As I indicated, this is transitional. The only reason that we've got this in our files right now is because Chrome.sln has not been converted. Chrome.sln has got GUIDs for all of the projects that it's got defined, and it's stitching them together to make all the project dependencies. For our checked-in Chrome.sln to interoperate with our generated VC proj files, we had to nail down hardwired GUIDs. Once we get everything converted, this is probably going to go away. Right. Right. The comment from Mountain View is that even if they're not pinned down that way, they end up being stable. Once it's generated, we'll keep it the same way. But Chrome.sln wouldn't know about that until you put it in there. So. Okay, dependencies. This section, there's a very small trivial example on the right-hand side. This is where you express in JYP the target level dependencies between things, different targets that need each other. What you're saying is that this target that you're defining, that we're defining over here in the skeleton, depends on or uses the other target. As I indicated before, this enforces order, and there are two effects that end up being important to most people working on this stuff. Is that the other target that you depend on can define build settings that have to get applied to you just because you depend on that other target. I already indicated the canonical example here is the way that we need to have every target that uses gtest, that compiles against gtest, define -d unit underbar test. Instead of implementing that by going to all of the targets in all of the other JYP files that use gtest and saying, oh, okay, I've got gtest that I'm pulling in here, I better make sure I'm defining the right set of variables. Instead, all we do is set a value in the gtest's definition that says, hey, anybody that used me has got to have this -d unit test. I'll show you that as we get farther into it here. The other effect is that if that other target that you're depending on is a library, JYP knows to automatically drag it into your link if you're an executable. So the upshot is that it actually ends up being a pretty nice, concise way to express these kind of build dependencies and have them